Jai Hind, everyone. Thank you very much for joining the post-lunch session, session 3. It's on emerging technologies and it's chaired by a very respected and regarded intellectual and Army Air Defense former DG, General Saxena. We have 3 speakers, each one of them expert in his own field. So without much ado, over to General Saxena. All yours to conduct, please. General Saxena.
Good afternoon to one and all. At the onset, I wish to convey my sincere thanks to CENJOWS and IMR for providing me the opportunity to chair this session. Ladies and gentlemen, this is a technology session. What is technology? Technology is a fuel. Technology is an enabler. Technology is a catalyzer, which has enabled and catalyzed players on both sides of the fence. While on one side, it has enabled the prosecutors of the air threat with phenomenal multiplicity in air threat vehicles, with tremendous lethality of munitions, and with latest in weapons and technology. On this side of the fence, it has enabled the air defense warriors with sensors which can detect a needle in the haystack, with shooters like guns and missiles which will not let an attacker go unpunished, and battle management and control system which can conduct an air defense battle with precision, with dexterity, and with efficiency. Today we'll see the shades of this technology, emerging technology in Army, in Navy, in Air Force as relates to air defense. My first speaker will talk about the emerging threats and technologies in the unarmed combat vehicles, in unarmed vehicles and swarm drones. Ever since the advent of the unmanned, the battlefield has never been the same. These dull, dirty and dangerous as we know them actually started their journey as a look-see vehicle with the capability to peep across the hill. Then they became vehicles which can carry out star missions, intelligence, surveillance, target acquisition, and reconnaissance. Then they came in their next avatar of combatized UAVs in which they could stand alone and fight a munition-driven battle. In their next version, they stood shoulder to shoulder with manned platforms in battle function called man and unmanned teaming. In this, they not only increased the situational awareness of the pilot many notches up, they also provided him unmatched enhancement in combat capability in taking on such targets which are either out of sight or not in the vision and sights of the combat pilot. And in their latest version, the unmanned vehicles as seen in the form of swarm drones. I will say swarm drones is a miniature of marvel of technology today. A swarm has a mind of its own. A swarm has got a degree of survivability. A swarm has an intelligence of a swarm as such, and it has tremendous lethality. Just to talk about the lethality of a swarm drone, we need to go back to 5th January 2018, when a swarm of only 13 swarms attacked an Air Force facility of Russians in western Syria at Khmeim and the naval facility at Tartus. It is interesting to know that Russians employed its state-of-the-art missile system Buk-2M in bringing down the swarms. In bringing down the swarms, just 10 of them attacking the airbase, they could bring down only 7. 3 of them still attacked and caused damage. The ones which attacked to the naval base were destroyed by soft kill weapons. Shift to 14 September 2019. Just 6 kamikaze drones attacked the Saudi oil facility in Abqaiq and Khurais. Within a matter of few hours, something like $5.7 million of million barrels of crude oil was stalled. The country's capability to produce oil was halved for that day. That is the level of lethality of the swarm drones. To tell us more about the emerging threats from UAVs and drones, I now invite Brigadier Shyam Murari to take on the stage. Brigadier Murari has been my DDG and I am very proud of his professional capabilities. Over to Brigadier Murari.
Good afternoon, everyone. I'm sharing a presentation on emerging threats from UAV and drones. I'm Brigadier Murari, and I've been DTG Army AD for the Army headquarters for almost 3.5 years, around 5 years back. Now, after superannuation, everyone is hearing, I suppose.
Yes, sir, you're audible, sir.
Yeah, okay. Then I'll go ahead with it. So, after having superannuated, I changed over to the industry and I launched my own company called Tatvo Technology Private Limited, which has got grant in aid from the government of India for making cutting edge CNT and graphene based body protection armor with embedded sensors. That is what my role now. But I got this opportunity to come over and discuss with you the emerging threats from UAV and drone. So I worked upon it and here is my presentation. I'll just share it with you. Now, I'll start from the introduction part. That is, you are aware that way back in 1849, it was Austria for the first time, they used balloons with explosive to attack the city of Venice. And since then, we know that gradually and very steadily we have gone ahead and made a number of drones and UAVs for the purpose of looking over the hills and looking around and having a surveillance to a very advanced autonomous vehicles. Now, very most of them, they call it as a dull, dirty and dangerous. How dangerous the UAVs and the drones can be, I'll show you in a film which has been made, which is a short film called Slaughterbot by a company called Alter, and it's made by Stuart Sugg.
Stochastic motion is an anti-sniper feature. Just like any mobile device these days, it has cameras and sensors, and just like your phones and social media apps, it has facial recognition.
Hello?
Inside here,
Hello?
3 grams of sheep explosive. This is how it works. Did you see that? That little bit is enough to penetrate the skull and destroy the organs. Let's watch the weapons. And trust me, these were all bad guys. Now that is an airstrike of surgical precision. It's one of a range of products. Trained as a team, they can penetrate buildings, cars, trains, evade people, bullets, pretty much any countermeasure. They cannot be stopped. Now, I said this was good. Why? Because we are thinking big. Watch. A $25 million order now buys this. Enough to kill half a city. The bad half. Nuclear is obsolete. Take out your entire enemy, virtually risk-free. Just characterize him, release the swarm, and rest is check. These are.
So what we have seen is a swarm technology with AI and autonomous in nature. So let's first see as to how these UAS, we call it as a unarmed aerial systems. Instead of UAVs and drones, we call it combined together as a unarmed aerial systems. And they have actually revolutionized the complete military affairs. This is one of the revolution which has been in a very short period of time with a quantum jump in technology and the lethality of the system. Some of the virtues that these systems have, the long range and altitude capable, tremendous endurance, all weather, and can carry any kind of weapon, and a very, very cheap and risk-free. And the task they can perform is stupendous, right from surveillance and intelligence gathering to battle damage assessment, to control and direction of fire, contaminated area recce, and emergency response. And for the civil task, it is endless actually, right from right control to personal transportation to urban planning and so on and so forth. Now, these UAS can be divided based on the kind of concept that can be used for. So, in case of the concept for use, it can be basically be off the shelf, which is commercially available. Then you can have the payload and then the weaponized threat. Hello, anybody a question something?
But I'm there, you can see me there.
I can see you.
Okay. So from the commercial off the shelf, they can be for nuisance value, they can be for interference, monitoring, and kinetic kill. For monitoring further, it could be for surveillance and recce. So far as the payload is concerned, it could be smuggling or any other payload which we have seen in the recent past in our areas of operation also. Then in the weaponized threat, it can be non-lethal, it can have projectiles, it can have even the weapons of mass destruction, which could be chemical, biological, or radiological weapon load. Then it can be IEDs and explosives, and finally electronic attack. This is as per the use that it can be of the US in the future. However, as per the drone policy of our country, which was promulgated in 2020 as a draft drone policy, we have further divided these into 5 categories, which are nano, micro, small, medium, and large, depending upon the weight factor. And also, they have a restriction of the height of operation and area of operation. Now, to counter this, we have to have a very systematic defensive method, and we call it as defensive depth layers of these defensive measures. And these can be further divided into the prevention part, which is right in the early stage, then the deterrence, then denial, then finally detection and destruction or interruption, depending upon the kind of weapon that we are going to use. Now, if you look at these the defensive in depth model, based on these, we have also promulgated in our drone policy of 2020, which is flashed on the right on the in the yellow boxes, corresponding to the requirement of, let's say in case of prevention, what we have done is that DGCA has been made the complete in charge of the surveillance of all areas in the peacetime. Then the flying zones have been further demarcated as red, yellow, and green. Green is free for use. Yellow have got restrictions. You got to take permission for that. And red is no bar. Red is all bar. You just can't, no fly zone. Nobody can fly over it. Then deterrence, we have a number of measures that have been taken, like license for UTM. That is for transmission, the control of these, you have to take license, those who are providing service for these. Then the drone ports have to take authorization and sanction from DGCA, from where they are supposed to fly and go around. Then the certificate of manufacture, each manufacturer, they have to be registered with the government of India and they have to take a certificate. And each chip has to be numbered and they must have a unique identification number. So each drone will have a unique identification number. Then we will have the NPNT, that is no permit, no takeoff. If you don't have the permit online, you will not be able to take off. The engine won't start. So that is how the digital control has to be superimposed on each and every drone. Then unmanned aircraft operator permit. Anybody who is flying beyond visual range, he has to have a operator permit for that. Then each of these drones you have to maintain a maintenance manual which can be checked by the government. So these are the deterrence measures which have been embedded into our policies so that people don't get into in a mood. Anybody and everybody can't take on a drone and start flying, which will be a great threat even during the peacetime. Then comes the denial. Denial again with similar measures of NPNT. Then geofencing. The geofencing is that all red zones will have their own geolocation mark, and this will be embedded into the chip of the drone itself. The moment you're trying to take off a drone in a red zone, the engine won't start. You will not be able to take off. You won't be able to take off. That is how the geofencing works. Then also the flying zones, which I have explained earlier. Now coming to the detection part. Detection could be active or passive in nature, which we are fully aware of. We have the radar in active measure and a passive, which will listen into the all transmission of the control systems as well as the GS transponders. And then you can pinpoint a drone anywhere in the geographical area. Then coming to the active defense, interruption is the first one where most of these anti-UAV systems are using is to basically locate the drone and locate the operator. And then you start jamming it or you start spoofing it or you send a signal which is a spurious signal. So the drone gets jammed and then they have a home on mode and they start coming on to their home or they come down and hover at that location itself, and then the measures can be taken to capture it. Then coming to the destruction part, it could be a direct destruction by a small arm, shotgun, WARHEADS, any of these. Then you will have the smart ammunitions, like we have the L70 PFPF ammunition there. The smart ammunition can be activated when you fire against drones and it will take on any of these drones in that area. Then you can also have the directed energy weapons, the laser or a high power microwave or a laser, depending upon what kind of system that is being used. And finally, capturing. Capturing could be net launch, it could be ground launch, or net could be launched even by a UAV. And then also, finally, trained birds can be used for even capturing these small drones. Now, to assess what will be the threat in our times to come, it is important that we look into some of the recent past incidents. And the first that comes in mind is on 5th of January 2018, where a swarm of armed drones attacked a Russian military base in Syria. As you're aware that there were 13 drones, out of which 10 attacked the airport, air base, and 3 attacked their naval base. Finally, they were taken down by very costly Panzer-S systems and other systems. And some of them crash landed after they were jammed and all. But what comes to my mind is, what was the final attempt? It was just a swarm of drones and innovativeness in using them. The swarm and innovation that comes out as a lesson from this attack. If you look at the 14th September 2019 attack, where 2 major Saudi oil installations were attacked. Again, there were a large number of drones. They had rudimentary controls, they had GPS controls, and they homed on to the particular location and then exploded, damaging the oil refineries of Saudis. And what was the result? The result was that almost 50% of the output of the complete was stopped for quite some time, and it was a great economic loss to them. Again, what was the outcome? Outcome was, what lessons we draw from this? Again, swarm and innovation. Now, next is back home in our country on 14th September, again on the same day, we had 2 US persons, that the son and father duo. They were flying near Rashtrapati Bhavan, and they went unattended. Finally, they were they were apprehended by the police. And again, what comes out is innovation. It can be used anywhere by anybody, and it can be used anywhere. There's no embargo of location unless and until you have control over it. So this again indicates that these have to be kept in mind. And another incident back home again, this was in the Punjab-Pakistan border areas. 22nd of September 2019, as you are aware, that 80 kgs of weapons were dropped in Punjab for the operation in J&K, and they were to be utilized by the Khalistan Jindabad force, that is KZF, and it was supported by the Pakistan's ISI and also to some extent by Germany. Now, what comes out is swarm. Maybe a question mark, why swarm? Because it was 2 to 3 on each day over a period of 3 to 4 days. It was 22nd to 27th of September that they kept sending it. So again, a very innovative way of using, very rudimentary kind of a US with payload carrying capability and GPS homing, and they went to a location, dropped their load, and that is where they were captured. Now, so finally, in nutshell, I take it a chance to just compress the complete emerging threat of US into 3 categories. One is the weaponized swarm with artificial intelligence. Second is autonomous weaponized US. And third is artificial intelligence with existing aircraft, submarines, and boats. So this is the upgrades of the existing weapon systems. And if you look at the complete, these 3 kinds, which will have across all the spectrum and across all locations. It can be from border areas, operation areas, to back home into hinterland, and from small, micro, mini to a large, as big as Boeing, that kind of a system which can be utilized in the future. This is where I can gaze into future, and these are the 3 things which are going to come in our future. Now, coming to swarm as such, which has been talked about much everywhere. Now, what it is basically swarm is an acronym of a smart warfighting array of reconfigurable modules. These are a large number of small UAVs and UAS. They have their own intelligence, which is pre-fed. They can talk to each other, and they are in a gridlock, and they can function in adverse situation and in degraded condition and quickly readjust and give the complete overall mission which has been assigned to them. Now, some of the tasks which can be given to them is a continuous hovering over a period, over a area of interest, and give a continuous information about it. Then it could be very quietly sneak through windows and bottlenecks, and then again go and collect information and give it a real-time audio and video. Then it could be keep watching over a period of area in a particular pattern. And again, you can have your own intelligence where pre-fed information, it can correlate, and if a target comes up, it can engage also. That is where there are ethical issues coming into play. But in future, we are going to see all these systems with completely AI embedded and autonomous in mode. Now, why these swarms are so much talked about and they are tools of warfare? Because they have a very low cost option. They hardly cost anything. And they have their mind of their own. You don't have to have a ground station and GCS to control them and keep guiding them. They can simply overwhelm the enemy. You may have one channel missile system which can fire at least 1 or 2 missiles, or you can fire a number of guns, but you can fire only in one direction or 2 directions. But the moment these swarms come in, they'll be able to overwhelm the complete air defense systems there and then destroy the intended target. Then, when given with the AI, they have the motivation, inspiration, intellect, and the resolve to do. Actually, it is like a human being, like a group of soldiers. Like one calls battle, this place is taken by the second one. Somebody takes on his LMG also and takes his Maxim also and goes ahead and fire. That is how these swarms are designed to be. One swarm is dead or destroyed. The second one comes and takes that position, and the grid is maintained, and they carry on with the task which has been assigned to them. So again, summing up, with the AI, they will have a collective intelligence. They will have a degree of resolve and inspiration, very autonomous, adapt to, respond to unexpected changes, disseminate information in loose groups and colonies. Immediately, they can disseminate to everyone, so loss of information cannot take place. Then you will have a multiple frequency operation. They can be frequency agile and frequency jumping, so that you cannot jam it also. Then they will have a group thinking, and multiple threats simultaneously can be taken on. And finally, they can also have memory, so that they can memorize their path which they have taken. They may not take the same path to come back. They can take a different path or the same path depending upon how they have been programmed. Now, there is a small video which shows
military drone launcher. A team of researchers from Voltec and NASA's Jet Propulsion Lab have settled on another way to launch drones in a hurry, shoot them into the air with a baseball pitching machine. The technique could allow future U.S. forces to launch quadcopter-style drones quickly and even from moving vehicles. U.S. forces are increasingly relying on drones as a means to conduct reconnaissance. Drones allow ground forces to gather information about hard-to-reach places, whether behind enemy lines or the tops of nearby hills. For infantry and groups, deploying a drone like a quadcopter is no big deal for mechanized forces fighting from tanks.
So that is how the swarm would be utilized in future warfare. What we expect from China and Pakistan, which is very pertinent to us in terms of near future. So China, in February 2020, there have been reports that they have developed helicopters as drones, which can carry a small quantity of ammunition, but a variety of ammunition, like machine guns, grenades, launchers, mortar shell, etc. And in 2018 also they have shown promise of controlling 1,000 drones simultaneously. And this was done on 7th of December 2017. So let's say in the operation in the times ahead, you can see helicopters carrying some weapons and dropping in the area of intended operation. This was also mentioned by the CDS in the morning today. Then coming to Pakistan, they have their own UCAV, which have been developed and called as Brig. And on the picture on the right side, it has matured over last 4 to 5 years. And we are likely to see this in operational area. And also they have negotiating with Chinese for 48 high-end Wing-Long 2 UCAVs, which are likely to be given to them. And recently they have also spoken to Chinese for use of swarm drones, which I am sure the Chinese would mobilize to them in case we go for operations against Pakistan. Now, some very briefly about the capabilities that we have in these areas. So HAL, as you know, have made an MOU with a startup called New Space Research Technology of Bangalore. And they're working on 3 systems called Alpha S, Robotic Wingman, and Ultra High Altitude Drones. Alpha S is something like a 1 to 2 meter long, capable of carrying 1.5 tons of explosive, and 30 to 40 of them can be assembled and put together on one Su-30 MKI or a Jaguar, which is modified for the purpose. They have a stealth body. They can be launched, and the drones take a speed up to 100 kilometers per hour. They can patrol area, identify a target, and take on. They have a data link with the mothership, and they work on a kamikaze mode. They'll go and finally dive down and attack the target. Work on this is at a very advanced stage, and we're likely to soon this in our skies too. Now, the second one is the robotic wingman. This is on a technology called MUMT, that is called manned and unmanned teaming. So we have the manned, that is the aircraft, which is the mothership, and unmanned drones, which are launched by the aircraft. And these unmanned drones and US are being controlled by the mothership. The pilot has extra work to do, but yes, that's the eyes and ears and weapons of a combat aircraft fighter pilot. Now, these, in our case, also called as CATS, that is a combat air teaming system, and they will be deployed and they will move ahead of the aircraft 100 kilometers. They will have their own radar and sensors, and they'll be equipped with precision guided munitions, maybe laser guided or precision guided munitions. They will also have a two-way secure data link to the mothership, that's the aircraft. And this is how the robotic arm wingman will work in our case. And finally, we'll have the ultra-high altitude drones. We'll be going very high, up to 65,000 feet. Mostly it'll be on a solar power system, which will work for weeks together. In our case, it is supposed to work for three weeks, and will give deep inside the enemy territory all the surveillance data and inputs from deep inside movements and all. So these are three high tech systems which are being worked upon by HAL, and we are likely to have in the near future. Finally, the autonomous system which is going to take place.
Officials of the U.S. Defense Advanced Research Projects Agency, DARPA, in Arlington, issued an SBIRS TTR opportunity, SBR, Monday, for the distributed, secure, and trusted processing for heterogeneous swarms of autonomous vehicles project. The project seeks to develop a powerful, scalable distributed computer and software development environment that enables secure and trusted collaboration and processing across a heterogeneous mix of autonomous vehicles on low size, weight, and power.
This is how I come to the end of my presentation. Thank you. I think I have I've taken more time than what was. I hand over to the chairman.
Thank you, Brigadier Murari, for taking us through a very comprehensive presentation, though you overshot the time very grossly. You took us through the classification of drones, defense in depth, threat from swarm drones, autonomous variety, AI, swarm drones and threat from China, Pakistan, and also the drone capability of India. Well, more of it in the question answer session. I now take on speaker number 2, invite speaker number 2. We'll talk about the developments in air munitions and delivery system. Then the munitions for an air warrior are actually the teeth of his air threat vehicle. For a ground soldier, it may be the sword of his edge of his sword, and the sea warrior may be the punch of his power at sea. In the case of air munitions and delivery system, there are 4 or 5 trends which have actually been revolutionized. The first trend relates to guidance. The guidance which started from a beam rider, simple beam rider guidance, took off from there into semi-active radar guidance, to active radar guidance, to fire and forget type of weapons, and finally the third party guidance where the weapon system can take the guidance to the target from a third party. The next pillar which has been revolutionized is precision. Starting from the Second World War of unguided bombs and rockets, today the precision is of sub-metric accuracy. The guidance is inertial. Guidance may be satellite, maybe radar, maybe hybrid, maybe laser, maybe electro-optics. It has been totally revolutionized. The next field which has been revolutionized in air munitions is the standoff ranges. The standoff ranges used to be from a few hundred kilometers. Today, we are talking of hundreds of nautical miles in the BVRAM capabilities of standoff capabilities of the weapons. This is a total revolution in air munition. The next point on revolution, which has been revolutionized, is maneuverability. There used to be level flight munitions today, but today there are munitions which can loiter, which can change course, which can wait for their prey, which can allow the friendly forces to pass through and attack at will, attack when directed. There are air munitions where there is a versatility of their use in manned as well as unmanned platforms in a common way. Today there are munitions which are network enabled. They not only communicate to their mother platform, they can communicate to other weapons in the vicinity. They can have lethality which can be tailor-made. Hello? There are also munitions which can carry out functions in a denied GPS environment. And of course, in the delivery system, starting from the person where the manned person was standing, and today we have internal ammunition base. We have an ammunition base with canted trapezy. To talk to us more about air munitions and delivery, I now invite Wing Commander M. Subramaniam to give us a talk on this.
Thank you very much, sir. Good evening, Chairman, co-panelists, industry experts, and the esteemed audience. So I'll be presenting on developments in air munitions and delivery system. I'll speak about this topic under the following headings. As flashed, I'll introduce the subject. I'll say why it is needed and how it has evolved and what is the track which we are following. Was there any vision? Is that the vision that we are following? All those things will be covered in the presentation. The reach and rapid reaction capability in combination with the extreme destructive power of air-launched weapons has made air power a dominant element in the art of warfare and national security. Air power was born in war, with air forces coming of age by 1918. That's the end of World War I. By the end of World War II, air power was recognized as an instrument of national power, created a new appreciation of time-distance relationship, provided a solution to the challenge of meeting the principles of mobility and concentration of force in the conduct of war. Air power can only be countered by air power. Hence, it became necessary to maintain a standing force. With the realization that air power is a force to reckon with, came the needs of economy of effort, rapid retargeting, low collateral damage, and clean battlefield area. With the recognition of air power and its needs, the air power evolved with the conflicts and wars it participated. Economy of effort was in focus, and with the advent of technology, saw the emergence of laser-guided bombs in the Vietnam War. The evolution of air power prompted military visionaries to envision concepts that would guide the future of air power. Reconnaissance Strike Complex was one such concept designed for coordinated employment of high-precision munitions linked with advanced sensors and wide area net coverage and automated command and control for near real-time responses. So what is Rook? This is what the artist's impression on Rook, which was thought of in 1980s. You see an aircraft which is lacing a target and a ground force which is attacking it. And there are some munitions which are smart enough to recognize a tank and attack only those. So these were the principles which were envisioned. And what are this vision of 1980 stand as of now? This is a snapshot of a global trend of wars of Desert Storm in 1991 to Iraqi freedom in 2003. Affirms the Rook concept, and it can be seen that the use of guided munitions has increased substantially from 10% to almost 70%. It appears that the technologically advanced world powers doesn't seem to disagree. They're all focusing on this concept and treading the lines of that vision. The convergence of the Rook theory and technology can be seen in the present-day weapons. The technologies of inertial navigation systems, terrain contour matching, digitized scene mapping area correlator, and GPS as a standalone technology or in combinations has been the backbone in mid-course guidance, and with IIR, that is imaging infrared homing and anti-radiation sensors in the terminal guidance, has realized the first element, that is the precision munitions. So what have these technologies done to our air munitions? We have graduated from laser-guided bombs of 1940 to the sensor-fused weapons in 1980. It's a beautiful weapon. You have to see it functioning. You'll realize that this is the reason why it was extensively used in Operation Iraqi Freedom. It's a smart area weapon, capable of multiple target engagements, designed to destroy combat vehicles, land and littoral targets. The technologies that are packed in this smart weapon are radar altimeter. The one which you are seeing is the radar altimeter, laser profilometer. It's a target sensor, active target sensor, and an infrared sensor, which is a passive sensor, and explosively formed penetrator. The one which you see is the explosively, which will form an explosively penetrating mechanism. And the center of the EFP designed to destroy armored targets, and the 16 peripheral mini EFPs. The dense what you see around here is the mini EFPs, which is designed to destroy the personnel. This technology abides by the requirement of a clean battlefield. If it doesn't recognize a target, it will self-destruct. It's not required to do an EOD for making the area safe. That is how the systems have evolved since 1940 to 1980, and it's further evolving. Now let's look at some of the promising technologies. Combined with revolution in thinking, which in due course of time would turn Rook concept into reality. The first of its kind is monolithic microwave integrated circuits. They call it as MIMIC shortly. These are circuits which are made of gallium arsenide. These systems provide high power amplification and low space and weight requirements. What are they capable of? They are capable of extending the range and power of our radars. This will enable MMW applications and high capacity bandwidth. That means you are looking at data transfer at rates which you have not imagined. Then comes the microelectrical mechanical systems, or the MEMS. This was pioneered by Richard Feynman in 1959. This technology integrates mechanical, optical, and other functions in a single chip. What are we looking at? We are looking at systems between 1 micrometer to 100 micrometers. Do you realize the size? The size of an animal or a plant cell. What is the technology capable of? It can make us have an accelerometer, which at present weighs 1.5 kgs and consumes 35 watts, to MEMS accelerometer, which will weigh only 10 grams and will consume only 1 milliwatt. The manufacturing technologies are such that this MEMS accelerometer can survive 100 kg of force. With microfabrication techniques like etching and surface machining, the integrated sensor plus circuit plus actuators can do invisible wonders and give you products like micro UAVs and excellent imaging systems. The third, precision inertial navigation systems. INS technology has been our oldest buddy. It has guided all through the way, right from the day we have invented it till today. So what we do? We improve on it. We do pins. What does pins do? Pins enhances it. The technology uses ultra-cold atom interferometers and lasers to reduce the positional accuracy drift of INS by several magnitudes to achieve near GPS accuracies. This technology attempts to realize the inertial forces at atomic level in a given period of time, thereby reducing your combination errors, which tend to gather over a period of time in the good old INS. The fourth is a micro-inertial navigation technology. We call it as MINT. When I spoke about MEMS, it was a component level, whereas MINT is a system level of integration. MINT seeks to create high-precision navigation aiding sensors that directly measure intermediate inertial variables of velocity and distance. This, by doing that, mitigates error by integrating signals from the accelerometers and gyroscopes. This tech will be greatly useful in our terminal guidance. And what are we looking at with this kind of technology? The IMUs with MINT would enable several UAVs to navigate in a close proximity without collision. We heard about the swamps from the previous speaker. It's a reality. With MINT coming up very extensively, you will find UAV swamps is no more a dream. It's a reality. Then we have the millimeter wave technology. The millimeter wave shares the features of microwaves and the IR waves, since their wavelength ranges between these two waves. the wavelength is 1 to 10 millimeters. MMW waves play a significant role in communication, radar, control and guidance, remote sensing technology, radio astronomy, etc. What are their capabilities? They have a good bandwidth with the capability to undertake large capacity satellite ground communication. So you'll have better maps, you'll have better comparisons when I go for a DESMAC kind of sensor. With a narrow beam antenna and low side lobe, performance of MMW antenna, we would create precise tracking radar and imaging radar at low elevation angles. Though they have a short target detection range, MMW, put along with the other technologies, are already part of our missile seekers. In long-range missiles, especially during a re-entry, MMW will help to penetrate plasma to make the communication, control, and guidance, indicating they are the technologies which are to be reckoned with, which will give us more precision in attacks. This is the first element, gentlemen, which I had told you, the Rook theory. Then comes the integrated high-performance turbine engine technology. This technology aims at 100% increase in the thrust-to-weight ratio. There would be a reduction in production and maintenance costs, and what we are looking at are the smaller and lighter engines to power our UAVs. Then comes the hypersonic air-breathing engines. One of the most feared technologies that has brought back the fear of Cold War. With Russia leading and China and USA closely following, indicates that the technology has matured. They have overcome the issues of high temperatures that occurs during free stream deceleration of air to subsonic speeds from hypersonic speeds. China presently has DF-26 missile, which with a range of 2,500 miles. It's a guided ballistic missile. It has got a predictable path. So you can intercept it if at all, if you have the capability. To overcome this, there are other technologies in the hypersonic mode, which people have thought of it, and it's almost a reality now. The boost guide missile that rely on aerodynamics lift is a reality with Avangard, a Russian missile which can travel at 20 Mach, and China's DF-17 with a range of 1,500 miles are in the category of boost glide vehicle. So once they are launched, they will go up to a certain height, and after that, it powers through the gravity, and they will be using a ramjet or a scramjet engine to achieve its task. And with advancement of scramjet technology, the category of hypersonic cruise missile is also a reality. What is the difference between the other two and this? This is maneuverable. You cannot intercept it. That is the kind of technology what we are looking at. And last but not the least is the artificial intelligence. People talk a lot about this artificial intelligence. With all these technologies coming in and having artificial intelligence, we are looking at what? We are looking at the last element or the third element of the Rook, that is automated command and control for real-time response. With all these promising technologies, the delivery systems, namely the aircraft, UAVs, UCAVs, loitering munitions, and lethal autonomous weapon systems, has enhanced the four generic capabilities of air power, namely awareness, reach, power, and support. The warheads and the energetic propellants have remained virtually unchanged for the last 40 years. This is likely to change due to the drivers like performance enhancement, cost, availability, toxicity, environmental effects, and safety. Otherwise, these combination with the other technologies which I had mentioned as the promising technologies are the lethality weapons which are in force now. So what are these emerging technologies? What are we looking at? A DESIROUS air combat situation, which at present day is a capability of advanced nations, and pushing them further to automated command and control for real-time response. So what is the way forward? Taking into account the global trend, Rook vision, and emerging technologies, what should be the way forward? We should channelize the emerging technologies in the application of information acquisition, information denial, overarching reachability, better situational awareness. This is what will lead us to be a successful nation with technology. So, gentlemen, to conclude, recognizing longer-term trends in technological developments and their potential impact and application is the key in long-range planning process. Revolution in technology combined with revolution in thinking would benefit the nation commercially as well as militarily. I have finished. Thank you very much.
Thank you very much, Bala, for taking us through a very comprehensive presentation which spanned the historical perspective, talk about the emerging era of the precision guidance, the journey from the dumb bomb to the smart and fused ammunition, the promising technologies of MMIS, MEMS, PINS, MINT, and so on. Not to talk about the hypersonic weapons, how they are revolutionizing the air munitions and delivery systems, and how the technology has been at the beck and call to make the delivery system more lethal, more unpredictable, and more accurate. More of it in the question answers. Let me now turn to speaker 3, and his subject is most interesting: emerging air defense technologies in naval systems. And then my experience has been that out of the 3 services, the Navy has been in the forefront of air defense technology, be it sensor, be it shooters, or be it battle management and control systems. As regards the sensors, long back the synthetic aperture radar, the active electronic scan array radar, the anti-stealth radar, they're already looking at some of these technologies in a very proactive way. Navy was the first one to put on air the GSAT-7 for the multiband communication spacecraft, and GSAT-7R is due any time now. Also, a read-through of the Indian Navy Indigenization Plan, INIP in short, 2015 to 2030, gives a viewpoint of what are they looking at in terms of air defense technologies. They're looking at anti-stealth radars, they're looking at quantum radars, they're looking at laser radars, and they're looking at MEMS, what Bala was just talking about. But at the present moment itself, they have the complete range of shooters and battle management system, not only sensors. If you talk about the guns, the old vintage old horse of AK-630s, the CADS, Kazan, 40mm, 30mm, and latest they got the Dutch Link U2. In terms of missiles, besides the Igla, OSA, SA-11, Barak 1, the Still missile, which is very useful, the Volna missile, which is useful, and Barak 8, which out of the 3 services has made the entry as LRSAM in the Navy as the first one. They're looking in future for the BrahMos Mark II hypersonic cruise missile and Nirbhaya missile. Navy is also looking into the directed energy weapons being developed from the laser and going on to other modes. The technology perspective and capability roadmap of Navy in 2018 gives the technology of sensors, shooters, and battle management systems. They are working on a very ambitious program, and the air defense technology of fleet at sea with the battle management and control system being provided by the ADCNR system called Trikun has already been tested a number of times in the battlefield. How the very number of ships at the fleet can be connected on a secured end-to-end encrypted communication has been shown in a number of exercises and in a number of battle drills. So I will invite the speaker from the Navy to tell us more about the emerging air defense technologies and the naval systems. Over to you.
Thank you, sir. Can you hear me, sir?
I can hear you. Go ahead. Your mic was muted. You can go ahead now.
Sir, respected chair, distinguished guests, ladies and gentlemen, I am Commander Inder Kumar Singh, Commander Staff Requirements Surface-to-Air Missiles at Directorate of Staff Requirements Naval Headquarters, which oversees formulation of QRs and undertakes procurement of weapons and sensors for the Indian Navy, including AD weapons. Over the course of next 15 minutes, I would provide an overlook of naval AD philosophy, emerging threats, and associated developments of future AD technologies in the naval domain. The scope of my presentation is as flashed on the screen. Starting with the air defense philosophy of the Navy. Air defense in maritime environment is quite similar, yet manifold different than AD concepts of Army and Air Force. There are numerous challenges that the sea medium poses for air defense. Primarily among them is the presence of large number of neutrals owing to freedom of navigation and overflight on seas. Further, the launch platform, that is the ships, are inherently in motion, and the parameters of its motion, including roll, pitch, and yaw, are quintessential in generating an accurate fire control solution. The maritime environment in itself is challenging with limitations of sea state, weather, clutter, and radar horizon ranges. A ship primarily is dependent on its integral sensors to identify and classify a contact. A ship is primarily dependent on its integral sensors to identify and classify a contact, which is further aided by the weapon and sensor grid. The naval fleet primarily relies on self-defense against aerial threats as they operate well beyond the radius of shore-based AD cover. Further, the threats from missiles are posed from all domains, including land-based launchers, enemy surface ships, submarines, and aircrafts. The anti-air warfare area shown in the diagram is the area usually prescribed by the operational commander within which the anti-air warfare measures are taken and which is kept under constant surveillance for the purpose of instituting such measures. The high-value unit, which you can see in the center, sir, to be defended is usually located at the center of this area, surrounded by concentric circles of AD escorts with associated weapon systems. The size of this area is determined by the time taken to detect, track, destroy, or divert an airborne threat. Within this area, a layered concept of defense in depth is followed, which has been told by the previous speakers also, sir. The outermost layer beyond the range of the surface-to-air missiles is defended by integral fighters operating from the deck of an aircraft carrier. The next layer consists of long-range SAMs. Thereafter, the target is engaged by medium-range SAMs. Moving closer, we have short-range SAMs that defends the area. Further, the engagement of target is undertaken by medium-range guns. Thereafter, the engagement is undertaken by point defense missile system with line-of-sight guidance and very high accuracy. And finally, the closest hard-kill weapon, that is the close-in weapon system, is expected to employ at a very high rate to fire and destroy the target as the last line of defense. Having seen the broad AD philosophy of IN, let's take a look at some of the key emerging threats in today's geopolitical scenario, as it is the threat that drives the development of an air defense weapon and vice versa. One of the primary emerging threats to the ships at sea is anti-ship ballistic missiles, also dubbed as an aircraft carrier killer missiles. These missiles presently are launched from land-based launchers, which uses a ballistic trajectory, thereby approaching the target with a very high terminal velocity and a high angle of attack, rendering conventional AD systems ineffective. China has been one of the early proponents of these missiles with various Dongfeng versions, which we have heard very recently, sir, which are tactically employed for its anti-access and anti-area denial role against American aircraft carrier. The missile is further evolving with integration of decoys and multiple re-entry vehicles, MRVs, making its engagement even more challenging. However, this missile is highly dependent on accurate update of target information, relying on a number of space and ground-based sensors forming the kill chain. The next emerging threat are unmanned vehicles, particularly swarm drones. It makes for an extremely cost-effective anti-access area denial weapon solution, which is being used both by conventional armed forces as well as by the non-state actors. Swarm drones are particularly used to disrupt rather than destruct by swamping enemy air defenses. The capability of these drones has been successfully demonstrated by a number of actors and can be used for strategic gains, for which the recent attack on Aramco facilities at Saudi Arabia serves as a timely rejoinder. Therefore, anti-drone weapons, both in soft and hard kill category, have become a critical component of air defense network. The next critical threat is from hypersonic cruise missiles and hypersonic glide vehicles. These vehicles use spacecraft guidance and re-entry trajectories to achieve hypersonic speed, which renders conventional AD systems ineffective. Some of the key challenges includes mid-course and terminal guidance at hypersonic speeds. Number of countries pursuing this niche technology, and the technology is presently in varying stage of development and deployment. Now moving to the salient aspects of naval capacity building in the field of air defense. As it is already brought out, IN has been at the forefront of developing and inducting state-of-the-art AD weapon in the form of MRSAM with a multifunctional radars. This niche weapon technology has been jointly developed by IAI Israel and DRDO, and other sister services have rightly followed. Having successfully proven its capability, the Navy has demonstrated cooperative engagement capability of this system, wherein joint targeting configuration has been used, where the interceptor has been launched from one ship on guidance provided by sensors of the other ship. Now moving on to some of the futuristic technologies, starting with electromagnetic railgun. Electromagnetic railgun as part of hypervelocity weapons. They are the conventional, as we are aware, sir, the conventional guns have reached saturation in terms of speed, ballistics, and ranges, elevate with induction of smart and precision-guided munitions. Thereby came the evolution of EM railguns, which uses electromagnetic energy to propel projectiles up to a speed of 2000 meters per second at ranges in excess of 100 kilometers plus. This gun acquires key advantage of capability to engage supersonic targets at extended ranges and low cost per shot with no gunpowder. Likewise, it comes with challenges of high impact force, limited barrel life, high power requirements, and low rate of fire. This weapon system is in advanced stage of weaponization and development by select navies. Now moving to the next and very important part as far as Navy is concerned, the directed energy weapons. Laser and microwave weapons are rightly the talk of the town, engaging targets at speed of the light. This technology provides key advantage of precision, variable intensity, ability to target many times, and being very cost effective. It also provides capability to engage the whole area of threat from hypersonic weapons to drones. Although it comes with its own set of challenges such as high power requirements, scattering effects, etc. This technology is in advanced stage of weaponization, such as you all must have heard the ongoing deployment of Helios on board US naval ships. Now moving to the next and equally critical technology, that is the ballistic missile defense on board ships. Such capability is an integral component of BMD architecture, such as AG system with the US Navy, which provides capability to intercept ballistic missiles during boost and re-entry phase. It provides an array of interceptors capable of engaging weapon ranging from cruise missile to anti-ship ballistic missile. This capability also warrants integration into an ecosystem of network ops and early warning sensors from all domains. Now moving to some of the decoys. Among the soft kill measures, active off-board decoys provide next generation of missile decoy system. These decoys are capable of maneuvering and are positioned along the path of incoming target to deceive it away from own platform. Some of the examples of such decoys are Nulka and Nomad. Similarly, radar obscurant fog acts as a combat multiplier to screen, blind, or deceive incoming threats. Modern obscurants such as graphite flakes can screen EM tracking and targeting system. Pandara fog system tested by US Navy is one such example of this soft kill measure. With the advent of high-speed weapons and corresponding interceptors, early warning of missile launch is critical component of AD architecture. Therefore, satellite constellations overlooking such launches with EM and radar payloads provide early warning of ballistic missiles, thereby enabling the BMD layered defense into play. These systems should be integrated with the network, command and control setups, bringing the whole area of weapons and sensors on common grid. Now to conclude, the rapid advent of air defense challenges demands concurrent development of counter technologies to remain ahead of the curve. Therefore, the course of the Indian Navy is steady on leapfrogging rather than tail chasing by research and development in this field and inducting cutting-edge technologies and innovation. Concurrently, as much has been talked in the morning, indigenization is an unwavering long-term target with impetus to impactful outcomes in pursuance of self-reliance and eventually self-sufficiency. Thank you and Jai Hind.
Friends, we have had a most interesting session. Technology session has always been very, very intellectually stimulating session. And the first speaker brought about the threats from the unmanned vehicles, the unmanned combat aerial vehicles and swarm drones in all its various shades. The next speaker talked about air defense technologies and munitions which are taking place in the fields of Air Force. What are the air defense, munitions and delivery systems? What have been the changes which have been taking place? He talked to us on developments in air munitions and delivery system in great length. He took us through various technologies which are promising as on today. He gave us a historical perspective. He talked about the precision-guided munitions, how they emerge over a period of time, how the journey has taken place from a period of dumb ammunition to smart weapons. He talked about a large number of technologies which are revolutionizing air munition, which are MIMS, MEMS, precision initial navigation system, MINT technology, the swarms which have come in a big way, and the hypersonic weapons. And how these technologies are revolutionizing the delivery system, how we are going in from at one point in time, the hard points under the wings to internal weapon base to canted trapezies and so on. The last speaker took us through the emerging air defense technologies and naval systems and talked about how in each of the verticals of the air defense, that is sensor, shooter, and battle management and control, the Navy is taking big steps forward. In terms of sensors, it is talking about the synthetic aperture radar, the SR radars, the anti-stealth radars, the quantum radar, the quantum radars, and so on. In terms of the weapons, it's already operationalized the LRSAM, looking at BrahMos 2 and looking at the Nirbhaya missile. And in terms of battle management, fully automated battle management and control system already tested on Trigun, and also the technologies which are talking in terms of swarm drones, talking in terms of decoys, talking in terms of the he gave a very interesting technology of radar form, which can defeat an incoming missile getting onto a ship and so on. In that category, this has been an interesting session, and I will take the opportunity to see if there is any questions in the discuss session and take it on if there are any. I don't see any questions in the discuss forum, so I am not able to open this one. Discuss. I can just check. There are no questions here. So therefore, thanks speaker, thank General Arora, as also General Vinod Bhatia for giving this opportunity to conduct this session. Thank you and Jai Hind.
Sir, may I thank you, General Saxena, sir, for having spared your time and been with us to chair this session, as also the other speakers who brought a wealth of knowledge for the benefit of the audience. Thank you very much. Sir, are you back? No. We are just in time for the next session. We'll have a 10 minutes break and start the next session at 1630 hours. Thank you very much, sir.
Thank you. Thank you very much, sir.